everyone. Here I am in a tie, ready to teach you some geometry. My name is Mr. Chu. I call this curriculum Brack Geometry. I had a student request in one of my videos, could you do a scale factor video, Mr. Chu? So here it is, finding scale factors. Scale factors are a ratio. So if you're someone who likes these type of videos, like this video. If you're someone like the student that requested it, that's going to subscribe to my YouTube channel, right over here in the corner is the subscription button. And I appreciate it because if I get more people to like my videos and follow me on TikTok and Instagram and subscribe on YouTube, my videos will be pushed out to more people to help more people. And that's what I'm doing here. A ratio means it's a fraction. So anytime that you've got a scale factor, you have what's called a dilation. Now, most people have heard of them dilating eyes, where your pupil gets really big and they make you wear those really dark sunglasses whenever they're looking in your eye when you're getting your eye health checked. But a dilation can mean it can get small too. But your pupil is still the same shape. So the important thing about a dilation is to know that the shape stays the same. If it starts out a triangle, it remains a triangle. If it starts out a circle, it remains a circle. In this case, if it starts out a rectangle, it remains a rectangle in example 1. But you need to know which is your image and which is your pre-image. Well, your pre-image is where you start. And this says, find the scale factor from A to B. That means A is what we're starting with. That is called my pre-image. And we're going from the small a to the bigger B, so the B ends up being my image. And you have to be able to identify those before you can move forward. Now, these are rectangles. You can go ahead and mark all these right angles if you'd like. So the scale factor ends up being a ratio that you usually will reduce. So let's go ahead and figure that out. We have to have the image side first. So here's my image. So the sides have to correspond. So they have to be in the same position when the orientation is the same. So the 6 will have to go with the 2. But we do the image over the pre-image. 6 over 2 equals 3. So we'd say the scale factor is 3. Well, you say, yeah, but what would have happened if I'd have picked the other one? Well, let's see. So let's go from 12. And that came originally from the 4, so 12 over 4 is still equal to 3. So it doesn't matter which ones you take when they are similar figures, and all dilations are similar. Now, what does it mean? We have all this stuff up here, but what does it mean? So you can take the pre-image length, any of the lengths on a dilation, you take the pre-image length, multiply it by the scale factor, and you're going to get the image length. Let's see if that's true. 2 times 3 equals 6. Yep. Let's try the other one. 4 times the scale factor of 3 equals 12. Yep, they both worked. So that's how you find a scale factor. Sometimes the problems get a little bit harder. So how would they get harder? They get harder because sometimes you have to have a situation where you're on a coordinate grid, and that's example 2 here. So example 2 on this coordinate grid, it says find the scale factor of the dilation from triangle RPQ to triangle R prime, P prime, Q prime. So that you know, the pre-image will always have regular letters if the image has primes. Now, I said if, because they could have A, B, C, and then D, E, F. But if they're using R to R prime, P to P prime, and Q to Q prime, that's called prime notation. So what is the scale factor here? So we've got a coordinate grid here, and we have this blue triangle, R, P, Q, and a red triangle, R prime, P prime, Q prime. And we're going from the small one to the bigger one. Well, when we went from the small to the big one here, we had a number bigger than 1. So any time that it's an expansion or your dilation got bigger, your scale factor will be bigger than 1. And any time that it got smaller, if we'd have gone from red to blue, then it would have been greater than 0, so it would have been a fraction, and it can't be negative. That wouldn't make sense in this case. Are there negative scale factors? Yes, but that's advanced geometry. That's several lessons down the road. So what do we do here? You have to find the links. So there are 2 links that are easy to find on each triangle. The third one is harder to find. Well, which one will be hard to find? This PQ would be hard, and P prime, Q prime would be hard. The only way you could do it would be to use the distance formula, because it's going to be an irrational number. Yes, you could use the Pythagorean theorem, but it's still going to be an irrational number, which means it's going to be a decimal you have to round. But let's look at the other links. So, how far is it from R to Q? Well, we're going from 1 on the y-axis up to 3. So isn't that 2 units up? Sure is. Is this one easy to find? Well, we're starting at 1 on the x-axis and going to 4, so that's 1, 2, 3. So we know that distance is 3. All right? Now, what about on the red one? Well, that angled side would be the hard one to find. But this one's not hard to find because it's going from 2 to 6. From 2 over here up to 6 would be 4. And on this one, it's going from 4 to 10, which would be 6. So now that we have these lengths, we can go ahead and do exactly what we did here. So remember, the scale factor is going to be the image length over the pre-image length of a corresponding side. So we have to do some corresponding sides here. So let's do this vertical and this vertical, since they both are vertical and the orientation's the same. So the scale factor would be the image's length. Well, which is the image? The image is the one that will always be the prime. Here's my image, and here's my pre-image. And you notice I said here's the pre-image, here's the image. So it's going to be 4 over 2, which equals 2. Now, let's do the horizontal now. The image is going to be 6 over 3, which equals 2. So the scale factor is 2. Now, you remember what we said that meant? That meant that if we take a side length from the pre-image and multiply it by the scale factor, we're going to get the image length. Well, let's do it. Pre-image length 2 times 4, or 2 times the scale factor is 2 equals 4. Yep, that worked. Now let's try the other one. Preimage of 3 times the scale factor of 2 equals the image of 6. So that is the way that worked out. Okay. So let me take, and we're going to do 2 challenge problems on this same grid. I'll go ahead and use that same one there. Same triangle there. Just to see if we can get this done, I'm just going to draw a couple of figures for you to try, just to see if you can get the basic ones. And remember, it can be any type of a figure. So we'll call them challenge 1 and challenge 2. Challenge 1. Find the scale factor from A to B. So there's A. There's B. This is 4. This is 3. This is 15. And this is 20. And then show that yes, indeed, that truly is the scale factor. All right, and I'll do a challenge 2 here. And this one is 6. And this one is 5. And this one is, and that went from A to B. And this one is going to go from C to D. And this is going the opposite way. So this will be a little bit different now. So, and this is 9. And this one's 2.5. So try these 2 challenge problems. I'm Mr. Chu. This is Brack Geometry, and I want to help you learn the math. Keep watching my videos. Comment, subscribe, follow, and like. And I'll see you next time.